So next, kinematic equation by calculus method. So we know that A is equal to acceleration is equal to dv upon dt, and the displacement and the velocity is equal to dx by dt. So A is the acceleration and v is the velocity and x is the displacement and t is the time in which used in these equations. So taking in which velocity limit is u to v, and taking time for limit is 0 to t. So u is the initial velocity and v is the final velocity for use for the integration. So a is the acceleration, dv upon dt, dt a के पास चला जाएगा, a into dt is equal to dv. So taking an integration with limit u to v in dv and 0 to t in a into dt. So taking integration both side with limit and apply the limit u to v, dv is the integration of v, and at dt, a into dt, the derivation is at, the taking a limit is 0 to t. Then after apply the limit in the value, v minus u is equal to at. So v is equal to u plus at. This is the equation number 1 derived by the calculus method. Then v is equal to dx by dt. This is a velocity, and the will be the into of the v into dt is equal to dx. Then value of the v put in this equation, u plus at into dt is equal to dx. Then integration, taking the integration for the time 0 to t, u plus at into dt, and taking the limit for the dx, limit is 0 to x. Apply the limit in the value of integration and taking the time 0 to t, taking the time in 0 to t for the u plus at. So apply the integration, u plus at into dt is equal to 0 to x into dx is equal to u into dt 0 to t plus distributive properties for apply and 0 to t plus at into dt is equal to 0 to x into dx. So apply the limit for the value of the integrations and the both side. Ut 0 to t is the limit, and at square, so at square upon 2, at square upon 2 limit is 0 to t is equal to x. The limit is 0 to x, the value of the integration, and then will we apply the limit. So ut plus half at square is equal to x. The value is after by the use the limit. So this is the equation. So this is the equation 2 derived by the calculus method. And find out the equation number 3. So we know that v is equal to dx upon dt and a is equal to dv upon dt. So a is equal to dv upon dt is equal to dv upon dx and dx into dt in multiply. So we'll be find out the dv upon dt is cancel out the dx to dx. So a is equal to dx upon dt is the value of velocity, and the remaining value is dv upon dx. So cross multiply a into dx is equal to v into dv. So taking a integration both side. So taking integration both side, and a into dx is equal to v into dv, and apply the limit for the displacement 0 to x and for the velocity u to v, initial velocity to final velocity. Then taking a limit both side. So a into x for the derivative of the integration a into dx is equal to limit is 0 to x, and the value of the integration is v square upon 2, because the v into dv is equal to v square upon 2 at taking a limit u to v, and the find out the value x is equal to v square upon 2 minus u square upon 2, and 2ax is equal to v square minus u square. So v square is equal to u square plus 2ax. This is the equation number 3. This is the equation number 3 is derived by the calculus method. So note down